I think it's
Okay.
running.
Yep, I think it's running.
Okay, so section 8.2, we're solving the equations using the quadratic formula, and it's 8, 20, 26, and 34. So I'm gonna start off here. So here we are doing, we're gonna plug this into this. So I'm gonna put this is my A, my B, and my C numbers. And so I'm going x equals negative, which is a positive 7. We do the opposite of this originally, and then we go plus, minus, radical. And in this step, we do use the negative 7, and it's squared, because it's right here, minus the 4 times the A times the C, all over your 2 times your 3, which I'm already gonna automatically say that that's 6, so I don't get it. And then, so we square that off, which is it's a positive 49, and it's still under a square root. You have a negative times your 3, which is your 12, or I mean, your negative 4 times 2 is 8, times your 3 is your negative 24. So then 49 minus 24 equals 25, and it's still under a square root. And then you get a 5 out of there. So now we're going x equals plus 7 plus negative 5 all over 6. Okay, so we know that here we have two problems that are, it's a 7 plus a 5 over a 6, because we're using these means that we're going to have two problems, one addition and one subtraction. So x equals 7 minus 5 over 6. This gives me 7, 8, 9, 10, 11, 12. Plug these numbers into this quadratic formula. So then we have, instead of x, we're going to use a t. So we have t equals, we use the opposite of that number, which is a negative 10, plus or minus radical. We get, and let me just, your b is your 10 squared minus the 4 times the 1, because there's an imaginary 1 here, and then your times your c, which is 26. So 10 squared is 100, and it's under the radical. Okay, we have a negative 4, so 4 times 26 equals 104, and it's a negative 104. So you're left with a negative 4, which in essence is and I'm gonna pull it out here. So you're left with a radical 4. You're pulled out with a 2i because of your negative. Okay, so that should be 2i up there. And then all over your 2 times a, which is 1, so it's just basically 2. So we got t equals negative 10 plus minus 2i all over 2. So then we can break this down into two equations, which is minus 10 minus 2i over 2, and t equals negative 10 plus 2i over 2. Now these can cancel these out, so this would go 2 goes in, t goes into the 10 5 times, and these cancel, giving me a minus I. Is that right? T, 2 goes into negative 5 times. Yeah. And then this one would be t equals negative 5 plus I. So in essence, your answer would be negative 5 minus I and negative 5 plus I. For this one, we need to always make sure that this side is always equal to 0, and if it's not, then you have to deal with this number, and the way you deal with it is you subtract that side and you subtract that side. So this makes it a 0. So now what you're left is 15t squared plus 7t minus 2. And you always need to make sure that you're descending with your t squared, your highest power down. And so now we plug it into the quadratic formula. And so it's basically t equals, we have a, b, and c equals 0. So then we have t equals a negative 7, because remember we do the opposite, plus or minus the radical. Now we use the number squared minus 4 times 15 times negative 2 squared. Okay, so this is 49 under the radical, and then here we're going, we know that these two equal a positive number. Negative 4 times your negative 2 is your negative 8, positive 8, excuse me. 8 times 15 is 120. So we have a positive 120 plus the 49 equals 169. And then that's still under that, so we use our calculator to see. So we're going equals 13, okay, all over, and we have 2 times your a, which is your 15, which is basically 30. 15 times 2 is 30. So then you have t equals negative 7 plus minus 13 all over 30. Now we have two equations, or two different problems here to solve. Plus 13 over 30, and t equals negative 7 minus 13 over 30. And so then we have t equals, so we got a negative 7, so we have 6 over 30, because we're doing negative 7 plus your 13, and then t equals, this is 13 plus 7, that's negative 20 over 30, and these can still be reduced. So then we go 6 goes into 6, 1, 6 goes into 30 5 times. And then 10 can go into negative 20 10 times, and 10 can go into 30 3 times. And then, so our answer.
Look at that very last fraction again.
Okay, hold on 1 second. So we got 10 goes into 20 negative 2 times, and 10 goes into 30 3 times. And then so we have for our answer t equals negative 2/3, comma 1/5. And the thing that I messed up here was when I was dividing. That's where I made my error. So that's the answer. For this last one, this is written backwards for me. So what I need to do automatically is we need to, since it's not equal to 0, we need to subtract the 72 to make that into a 0. But for me right here, I have to rewrite all of this. So I would go 3p squared plus your 50p equals 0. Then I would plug everything into my.
What happened to your negative 72?
Oh yeah. So, and then this would be my negative right here. Because what you're doing, let me back up. Let me back up here. Okay, to start off, we subtract the 72 on this side, and we need to subtract the 72 on this side. This becomes a 0. And so we're gonna rewrite everything to 3p squared plus 50p minus the 72 equals 0. Now we can plug our numbers. So then this is our A, this is our B, this is our C. And then so we have P equals, and then we have a negative 50 plus or minus the radical, the 50 squared minus the 4 times the A times the negative 72. Okay, so we know that this is 50 times 50 is 2500 under the radical. Okay, now we know these two numbers are going to become a positive, so if we go 72 times 4 equals 288 times the 3 gives me 864, and it's a positive. So 864 plus the 2500 gives me 3364, still under a radical. So then we go in and we plug that number and see if it comes out to be 60. Okay, all over your 2 times.
Did you plug the right number in when you did that square root?
Oh, let me see here. So we got 2500 plus your 864. That's 3364. Is 58. Is 58. I made a mistake entering that. So then 2 times your A would have been 3, and that's basically 6. So now what I have left is P equals negative 50 plus or minus 58 all over your 6. So now we have P equals negative 50 plus 58 all over 6, and P equals negative 50 minus 58 over 6. So then here we have P equals 50 minus that 58 is just 8 over 6. Yeah, that's right, 8 over 6. P equals, and we're gonna add these two, 58 plus 50 equals 108 over 6. And then, so P can still be reduced. 2 goes into 8, 4, 2 goes into 6, 3, and then 6 goes into 6 once, and 6, 108, 108 divided into 6 is 18. So P equals 4/3 and 18.
Now, before I turn this off, look at the very last part of your two problems. You've got two problems there. Look at the second problem. Do you see what one I'm talking about?
This one?
Yeah, look at that one.
Okay, let's see here. So we got P equals a negative 50. Oh, that should have been a negative. So this is a negative 18.
That's right, yeah.
So I would do P equals negative 18, comma, 4/3.
Yes,
Scratch that out and do that here.
yes.